As everyone knows, the air filling your lung contains oxygen gas, but have you ever wondered exactly what is that you are breathing? The gas that you are inhaling is not made up of isolated oxygen atoms. Oxygen atoms are extremely reactive and your lung might be explode. That is why you are breathing oxygen molecules. So, what is molecules? A molecule can be defined as a collection of atoms bind together. For example, we take oxygen molecules. Can you guess what is binding them? So, here come intermolecular forces. What is intermolecular forces? The forces that holding molecules together. It can be in form of attraction, or repulsion that acting between neighboring particles. The forces can be divided into two broad categories: van der Waals forces and hydrogen bond. Van der Waals forces can be further divided into London dispersion forces and dipole-dipole forces. Van der Waals forces was discovered by a Dutch scientist, Johannes Diederik van der Waals. Firstly, we are going to look into London dispersion forces. Every single of nonpolar atom, or molecule will contain a positively charged nucleus. This nucleus is surrounded by negatively charged electron. At normal condition, these electrons are distributed evenly around the nucleus. At any instant, the electron will move to one side of the atom, producing unsymmetrically distribution of electron around the nucleus because of the constant motion of the electrons. The atoms or molecule can develop a temporary dipole, and it will induce the neighboring atom or molecule and lead to an electrostatic forces attraction between two molecules. This forces is called London dispersion forces. So London dispersion forces can be defined as a temporary attractive force that results when the electrons in two adjacent atoms occupy positions that make the atoms form temporary dipoles. There are two factors affecting the forces: molecular size and molecular shape. Molecular size. The larger the atom, the more electrons it's contained, and the stronger the temporary dipole forces. If the size is smaller, the less the electron inside it. Molecular shape. For example, a straight chain butane molecules will have larger surface area contact and will contain more electrons, so the forces is stronger. If compared to 2-methyl-butane, which the structure are more spherical and compact. Due to that, the surface area contact will be less and contribute to weaker London forces. Next one is dipole forces. It occur chloride molecule chloride. In nonpolar molecule, the negatively will attracts molecules charged positively for part charged of example hydrogen chloride of hydrogen. The forces arise as dipole-dipole, which can be defined as attractive forces between the positive end of one polar molecule and the negative end of another polar molecule. Finally, the strongest intermolecular forces of all is the hydrogen bond. Can only occur between polar molecule which contain at least one hydrogen atom that covalently bonded to a highly electronegative atom such as fluorine, oxygen, and nitrogen. Hydrogen bond can be observed between water molecules. So the definition for hydrogen bonding is attractive interaction between an electronegative atom and a hydrogen atom bonded to another electronegative atom.